My name is Nick Colt, and I lead product management and developer advocacy for container services at AWS. And that's what we're going to be focused on here today, specifically talking about containers on AWS. Just a little bit about myself. So I've been at AWS for 2 years. Before that, I was actually an AWS customer. So I'm familiar with both sides of the fence here. And I find that experience as a customer to be super helpful now that I'm actually working at AWS, because customer obsession is, one of our top leadership principles that you're going to see sprinkled throughout today. So I've got the term modern applications here, and I want to spend a little time talking about what is a modern application. What does that actually mean? So as I mentioned already, it starts with customer obsession. How can we help our customers be successful? If you're a business or an enterprise of any kind, running IT, looking at running in the cloud, why are you doing that? What are you trying to achieve? Well, commonly it's ROI. You're trying to get the most bang for the buck out of the investments that you're making. You're trying to reduce your total cost of operation. You're trying to make your developers super efficient, because as much as people might focus on your cloud bill, the fact is for a lot of organizations, it's the cost of the people that's the biggest thing that they're paying for. It's paying for your staff working on all of the things that they're trying to do. And the more that you can make your developers efficient, the better you can make your business agility, the faster you can turn around improvements, the better you can compete in the market, and the more successful you can be as a business. And so specifically with modern applications, what does that mean? A business today, especially an internet-focused business, you need to be prepared to scale to millions of users. All right, you may start with a small MVP, but things can change overnight, and your technology has to be ready to scale to millions of users. Global availability. It's not enough to launch in one part of the world, in one city, in one state, in one country. You need to be ready for global availability. Respond in milliseconds, right? With a mobile application, people looking at your site, at your app, they're going to wait half a second, maybe a second, and then they start to get impatient. So you got to have applications that respond quickly. And data, the quantity of data. As mobile networking gets faster and faster, 5G, as broadband becomes more and more globally available, the quantity of data that an application has to process is just continuing to explode. So these are the hallmarks of what we think of as modern applications and the benefits of modernization. So containers are a very popular way to modernize. This technology in some form or another has been around for a while, but it really started to get popular in 2014, 2015, because it introduced a new way to package code, a new way for developers to become more agile, because they could develop code in one place and have a much higher assurance that when they deploy that code in production, it's the same code. It's not like the old days of, well, it works on my machine. Why doesn't it work in production? With a container, you have a much higher assurance that what you run in production is the same as what you were testing, and all the dependencies. And in fact, if you talk to analysts, you'll hear them say that over the next several years, you can expect 75% of organizations will be running containerized applications in production. And containers are growing just hand over fist every year in popularity, especially for new application development. I think, at least anecdotally, when I talk to customers and I talk to them about new applications that they're building, it's extremely common for them to be choosing containers to run those applications. So when you run containers on AWS, a customer looking at our offerings today, they see a lot of choices. And sometimes, we get asked, why so many choices? Why do I have all these different options? And the short answer there is, it's the right tool for the right job. We have a lot of customers. Every vertical, every market segment you can think of, we have customers on AWS, and we have customers in containers building applications for those markets and in those verticals. And because of that, the variety of need, the variation in requirements is just tremendous. And so we have services to try to fit that entire broad spectrum of needs. So one of the first things people will ask us about is, well, you have two, quote, orchestrators. You have Elastic Container Service, and then you have your Elastic Kubernetes Service, ECS and EKS. And how do I choose between those? Why should I use one or the other? What we find is lots of customers choosing one or the other, and you'll find some customers who are just super happy and excited and successful on one, and you'll find the same thing for the other. And people often want us to tell them which one is, quote, better. And, the answer is it depends on who you are and what your use case is and what your expertise is and what you're trying to accomplish. They both can enable you to build modern applications, to have that global availability, to get those, millisecond response times and handle petabytes of data. And I've got some customer examples I'm going to show of customers achieving those kind of things.
Nick, sorry, quick question. Is there any relationship between the size of the customer and the service that they choose?
Not really. I mean, you see on both of those customers of absolutely gigantic scale running on ECS, running on EKS. And you also see everything all the way down to tiny little one-person, two-person shops running on both as well.
And what about skills then? So, the skill set of the company, does it play a role?
That definitely does play a factor. If you've got prior Kubernetes expertise, you're probably going to find EKS to be a natural fit because it is CNCF compliant Kubernetes. So all that expertise that you've built on Kubernetes applications, you're going to be able to take that and get up and running quickly on EKS. So absolutely, we do see that as being, one of the decision factors is if you've got that prior expertise on Kubernetes, EKS is absolutely a natural choice. And we think, and a lot of customers agree, EKS is the best Kubernetes experience out there.
So if I may ask a question about this slide specifically. So I think I know the answer, but I just want to clarify the way this slide is structured. It kind of reads vertically like ECS plus EC2 plus ECR. Is that the way I should read this slide, or are these options without any relation between the vertical axis?
No, they definitely, I wouldn't say that there's a column on the left and a column on the right. I see what you're saying, and it's not intended to portray that the left side all goes together and the right side all goes together. It's more that the choices on each layer can all work together. So for example, you can be an ECS customer and choose to run your containers on Fargate. I'll get in, if you haven't heard of Fargate, I'll get in a moment on what Fargate is. Or you can be an ECS customer and choose to run your containers on EC2 instances. Likewise, you can be an EKS customer and choose EC2 or Fargate or both. Both of those services make heavy use of the container registry. That's where the container images, those effectively deployment artifacts, are stored is in ECR. Although you don't have to use ECR, you can use your own registry, you can use a third party. The service mesh works with both as well. Yep.
Hey, Nick, real quick. You mentioned a second ago that the EKS service is CNCF compliant. Does compliant mean it is compliant, or are you adding any functionality that anyone should be aware of, like from adding additional things on top of that native experience?
So I probably should say conformance. I think that's actually the correct term. So if you want to call an offering Kubernetes, there's effectively a process for ensuring that what you're offering actually is Kubernetes. And we've gone through that process. And so EKS is Kubernetes. And Kubernetes, you know, what is Kubernetes? It's really a core set of APIs. And those APIs offer a certain set of functionality for things like starting up pods and scaling a cluster and what's the life cycle of a pod. There are things that live sort of outside of those core Kubernetes APIs. For example, what are you running Kubernetes on? What is actually running those pods? Kubernetes doesn't, that's not part of, by design, is not part of Kubernetes. And so you actually see that represented in this slide here, because when you run EKS and you create a cluster and you run workloads on EKS, you're running those on EC2 instances on our virtual machine offering, or you're running those on our serverless container offering, Fargate. And EC2 and Fargate are not, those are not Kubernetes APIs. Those are AWS APIs that Kubernetes is using. That's the same approach that you take no matter where you run Kubernetes. You know, if you run Kubernetes in your own data center, you just go download the open source Kubernetes and run it. You've got to go provision the compute infrastructure to actually run those compute nodes, and Kubernetes doesn't really do that for you. That's by design. Does that answer your question?
It does. I was just curious because I heard the term that compliant, and that means a lot of different things. So I was just
yeah. I mean, it's really conformance, I think, is the correct term, and it's really talking about those Kubernetes APIs. But we have things like managed node groups on EKS, which is not a Kubernetes API. That's kind of a layer that sits in between the Kubernetes APIs and the AWS compute infrastructure to make it really easy to configure groups of compute nodes in the way that you want so that they can be easily used and upgraded with EKS. So that's an example of something it's not exactly an extension of Kubernetes because it's not a Kubernetes API, but it just makes it easier to use Kubernetes on AWS because we're building a bunch of bridges for you to those core compute resources that you need in order to actually run Kubernetes. Okay. And kind of on that topic, Fargate, I want to spend a little bit of time talking about Fargate. So what is Fargate exactly? Well, what it does is it enables you to run containers without having to run EC2 virtual machines. So, normally back before Fargate, if you were running containers on AWS, the first thing that you had to do was fire up an EC2 instance, and that's running a operating system, and you as the customer are responsible for picking the instance type, which family and which size. You're responsible for the operating system and upgrading that operating system if there are patches to be applied. And a lot of people like that. They want that level of control. But especially as you start to look at maintaining these things over time, that can get pretty labor intensive. With Fargate, there are no instances. There's no operating system that you're managing. There's no instance type that you're picking. What you do is you specify the resources, CPU and memory, that your containers need, and then you just ask Fargate to run them, and the containers run. And that works with ECS or EKS. And you only pay for the CPU and memory that you request for those containers. So if you're not running any containers, you're not paying anything on Fargate, which is different than if you're running virtual machines where you might have a cluster running and have 10 virtual machines. If you're not running any containers, you're still paying for those virtual machines. And so you have to spend time like managing the utilization of that cluster. And some customers are really good at managing cluster utilization, and they can get super high efficiency. But a lot of people struggle with that. It's hard to get it right. And Fargate just takes that completely away. There's no cluster utilization to manage because there is no cluster effectively. You're just running containers, and however many you're running, that's what you pay for. And if you're not running any, you don't pay anything.
So Nick, real quick on that. Is it fair to assume, or is it fair to look at Fargate versus Kubernetes? Kubernetes, I'm passing manifests and all these different things to actually send to the API and spin up these pods and all that. From Fargate, I just say, hey, I need to run this container, and it's going to be short-lived, and I just send it to Fargate and let it do its thing, and it tears it down and goes on?
It's really both of those, actually. So Fargate does not have an API that you can use directly. You use it through ECS or EKS. And the way that you use it is a little different just because the ECS and EKS APIs are different. On Kubernetes, you effectively mark a pod to say this pod should run on Fargate. And then what happens is behind the scenes, we make sure that actually runs on Fargate for you.
Okay.
As a customer, as a Kubernetes user, it's a pod just like any other pod. You've just you can do it at the cluster level, where you can just say everything in this cluster should run on Fargate, or you can do it at the individual pod level with annotations to say this pod should run on Fargate.
Okay.
It's a similar type of thing. I mean, the specific APIs and terminology are different on ECS, but it's a similar idea that on ECS, when I run a task, which is the equivalent of a pod, I can specify, do I want this to run on Fargate? Do I want it to run on EC2? The actual code that runs, I can take literally the same container and I can run it on either one. I mean, there are a few constraints there, like Fargate doesn't have Windows containers. So there's a few little sort of compatibility checks, but the vast majority of containers can run equally well on EC2 instances or on Fargate.
Sorry, Nick. Can you, I mean, maybe it's an oversimplification, but we think about Fargate as a worker nodes as a service, something like that?
I would hesitate to call it that, because if you say worker node, it kind of implies a certain level of access and control, which you don't have with Fargate. I mean, to put it another way, one of the things that we talk about at AWS, and it's a very important distinction, is this shared responsibility model. So when a customer runs on AWS, there are some things that they are responsible for, and there are some things that we are responsible for. We're responsible for the infrastructure, the power, the networking, security of the data center, the physical hardware, the virtualization, like how does that virtualization system work? When you're running containers on EC2, the boundary of that shared responsibility model is effectively like the operating system. So stuff that happens inside the Linux operating system, that's the customer's responsibility. Not because we're not going to poke inside your virtual machine. Like we don't do that. That's your responsibility. On Fargate, the boundary of the shared responsibility model is different. The shared responsibility, the customer is responsible for what's inside those containers, right? But not anything outside of that on that compute infrastructure. So AWS is actually responsible for more, which is a good thing. That's taking operational load away from the customer. There's less stuff that they have to think about, less stuff that they have to worry about. But that does mean that I would be hesitant to call Fargate a worker node as a service, because that would imply something about that shared responsibility model, which I don't think is true. But it's not a worker node that you own. It does manifest on Kubernetes. Fargate manifests because of the way Kubernetes works. It can look like it's worker nodes coming and going, because Kubernetes does not have the concept of a pod running with no node behind it. So if you actually inspect the Kubernetes APIs, you will see what look like nodes, but we don't give you access to those nodes. We think of Fargate as serverless containers. It's not the same as serverless functions, because it's not the function-based programming model. but it shares a lot of similarities with serverless functions in that you don't pay for idle, right? You don't pay if there's no containers running. You pay for the resources, and there's no servers to manage. So it's got those kind of core serverless tenets in common with serverless functions. We do also have on the EC2 side a number of different compute options that are getting really interesting for customers in terms of where their compute runs. So Outposts, wavelength, local zones. I'm sure you're all familiar with the AWS regions like US East 1, et cetera, that we have around the world, 20 plus regions around the world. But in the last year or so, we've launched a number of additional compute options. One of those is Outposts. So Outposts is a rack, effectively, that you can have running really anywhere. You can put it in your data center. It's all the same core compute APIs for AWS available on that rack that's sitting in your data center. And EKS and ECS actually work with Outposts. So now you can take an ECS cluster and actually have some of those compute nodes running somewhere outside of an AWS region in your data center on an Outpost. And then wavelength and local zones are some extensions of AWS regions. So wavelength is partnership with mobile telecommunications to provide compute capacity that is co-located with telecommunications edge locations so that you can have your compute sitting much closer to where the users are. So for things like high bandwidth, low latency mobile applications, you can actually get that compute to be much closer to where those end users are. Local zones is a similar concept where we extend the idea of an AWS region to include a smaller availability zone that's not a full scale availability zone that's sitting closer to where key customers are. And then we have things like Graviton, which is the ARM-based CPU Graviton 2 instances that have really awesome price to performance ratio, and container services just work with those. You can use ECS and EKS with those Graviton instances to get that superior price to performance. So that's kind of a pretty long on this slide, but I knew I would spend a lot of time on this slide and there would be questions about it. I do have a few examples of customers that I just want to run through here, just to make some of this a bit more real. The domain group is an ECS customer, and they're an example of a customer that achieves what we think of as this powerful simplicity of ECS. So they were looking at how could they scale to meet the demand of their application while keeping control of their costs. And that's what auto scaling is all about. Auto scaling is all about making sure that your application runs enough, but not too much, runs enough to meet demand, but not so much that you're paying more than you need to. And so they were using ECS on EC2 with cluster auto scaling, and they were really happy with the scaling that they were able to achieve to meet the demand for traffic. And they were actually able to cut costs in doing this. So this is an example of that we talked about modern applications and the need to scale to meet demand. This is kind of a hallmark of a modern application that they were able to achieve on ECS. Likewise, you have customers like Snap running on EKS, running at this is just an astounding number, this 2 million transactions per second. Snap is obviously running with a very large number of users worldwide. They're an EKS customer, an ECR customer. And so they had this project of breaking up monolith into microservices using EKS, which is a common pattern that you see. And a lot of times those efforts start out as as an effort to improve developer productivity, right? Because you want these loosely coupled teams that can innovate independently of each other. But in this case, it actually improved their performance as well. Because once you got your monolith broken up into microservices, now you can scale those independent microservice components to the right level elastically using the AWS infrastructure and get the right balance across your application in a way that's really hard to do if it's a monolith. And so this is just one of those examples of a really big customer running at very large scale on EKS. Last one I wanted to mention is Talaflow. We just published this case study. And so Talaflow started out wanting to manage their costs. So they went through a re-architecting process and re-implemented this application on Fargate. And they actually found not only were they able to cut costs by 2/3 per cost per customer, but their application actually became more reliable as well because it was simpler, because they took away a bunch of management that they had to think about, a bunch of operational concerns. Fargate just took all that away, and they were able to focus on the core business logic of their application and make it more reliable. And in this case, actually, they were using a specific thing called Fargate Spot. So if you're familiar with EC2 Spot, EC2 Spot is spare capacity. Effectively, it's compute instances that on-demand EC2 customers don't need. And so we sell that EC2 Spot capacity at a lower price in exchange for which it can be taken away. So if you've got applications that they're more elastic in how much compute they can use, and they can tolerate a loss of compute capacity temporarily, EC2 Spot's super attractive. And about a year ago, we launched Fargate Spot, which has similar characteristics. You get a reduced price up to 70% less than Fargate, in exchange for which there's the possibility that your compute capacity could be temporarily taken away if there's a loss of that spare capacity. So a lot of customers have applications where they're like, yeah, you know what, I would like to get this work done faster if I can. If I can get a bunch of extra capacity for a cheap price, I'd be very happy to get that. If my application loses that capacity, it's not like I have downtime. I still have other capacity running, but that way I can get like extra bang for the buck. And Talaflow is super happy with that they not only cut their costs, but improve their reliability.